Hi, welcome back. I am starting with question 5. This question was a bit tricky because of the nature in which the diagram is drawn. So what I did is I have drew my diagram here. It's not to scale, so don't criticize me. And I take the top part off, this ACB part, and I put it next to it. So it sort of like turns, right? So what I've created then is I took these two triangles and they are similar because this one is the larger one. But you can see how it turns. B is here and A is there. So I'm just going to write in the information I have. I know that side AB is 32, so 32 is here. I know that side AC, this side here, is 36, so I'm going to write my 36 there. And I know that DE, which is this one here, is 24. So looking at these two similar triangles, I know that these two sides therefore are similar. Or let me just write another way. I'm going to take triangle DCE, triangle DCE is similar to triangle BCA. This information is I'm going to use. So what I'm going to do is we are going to take the first two. So I'm going to have DC over BC is equal to. Then I take the last two, right? So CE over CA. While you're here, you can already solve the question. I'm just bringing that extra point. Then you take the first and the last, that is side DE over BA. So once you now complete and you put in your values, you realize we know that DC, we don't have what DC is. We know that BC is also not there, so we don't really want anything to do with this. Remember, going back to diagram, we want the distance from A up to E. So the only thing that we really need is we need this little distance from C to E, and then we add it plus 36 more in order for us to find A up to E. So I'm really interested in CE, which means I'm going to work with this particular part because there is nothing here for me to calculate. So CE is what I'm looking at, okay, over CA, and CA is 36, all right? CA is 36, and I know that DE is 24 over 32. So I have a complete ratio here, and I have got a part that I'm looking for over 36. So when I do this 24 over 32, if I multiply it by 36, because in order for you to get rid, this is going to give me CE. So CE is 24 over 32. Multiply that by 36, sorry. You're going to get an answer if you punch this in on your calculator of 27. So now, if I go back, I know that CE is equal to 27. So A to E is going to be AC, which is 36 centimeters, plus CE, which is 27. And adding the sum of that, you get 63 centimeters. So you gotta have an image in order for you to know how to approach this particular question. You can either use this way where you take that top part off, put it next to it, careful that turning your B is now this side and so on. And then you can already work your way from here. You take this over that, and you have got this over that, or the other way around. It doesn't matter. You can have, what I'm saying is you can have 36 over CE, because I started with big one, and then 32 over 24. Once you do your cross multiplication, you'll still get your 27. Or you can have the other way, where you take the smaller one first, the CE on top, like what I did here, the 36 under. Because of cross multiplication type of calculation, you are going to get to the 27. Most of the people only ended at 27, and that was where they got it wrong. Question 6. Now, you have got two particular figures, and they are all similar. We are supposed to calculate our x. In this particular case, in this A part, the x is a length of a side. But what are we given? We are given the area. Here, the x that we are supposed to find is the volume, because of that unit tells you. But we are given the length. So we will have to find the volume in this case, and in this case we have to find the length of the side. So when I look at A, if you look at, and it doesn't matter if I take the small one, let me talk about the area scale factor, because it's what I'm given here. The area scale factor, 27 over 12. Just put this, as an improper fraction. Now, before I find 12 goes how many times in there, I would like to find that fraction. And this fraction, if you simplify, is 9 over 4. Now, for me to find the length scale factor, okay, I need to take the square root, because this is area. So in order for me to find the length, I will take the square root, because I want to find what is the ratio of the lengths. So the square root of 9 over the square root of 4 is the same thing as somebody doing this, but I prefer that method. Anyway, the length scale factor is going to be 3 over 2, which is 1.2, 1.5. So now I know what this is. I want to find x. Since x is the smaller distance, I want to find the smaller distance. I will say the 6 times by the proper fraction, because I must make this small, all right? Because if I multiply it by 3 over 2, I'm going to get a very big number, and I'm looking for the smaller distance, so times 2 over 3. And if you multiply that, 3 goes there 2 times, and 2 times 2 is 4, and that is how that particular question is done. No need there to calculate the volume scale factor, because we are not asked the volume, but you can still do the volume scale factor if you wish to. That means you just take this value and you cubed it, but there's no need for that. In this particular case, I have the length scale factor because I've got 9 over 8 corresponding lengths. I want to find the volume scale factor. So nothing to do with area. To find the volume scale factor, you take this 9 over 8 and you cube it. Now, it's going to be a horrible number. It's going to be 729, if I am not mistaken, over 512. So I'm going to take this 30, because I'm looking for a bigger value. I'm simply going to multiply the 30 by this. Suppose I was looking for a smaller one, I would put the 512 on top. All right, so if I put 30 times, so you have to use your calculator to be on the safe side. All right, don't try to be like Mr. Mix. You're going to get a horrible number, which you need to, there are people who probably will write 42 and 183 over 256. This is an exact answer, but because you're dealing with Cambridge papers and the degree of accuracy, they want to always for you to give to 3 significant figures, because if you punch this in, you get 42.714, blah, blah. Now, since they wanted to 3 significant figures, it's 1, 2, 3, the correct answer, therefore, will be 42.7. Many of you could not get that answer. That was the particular answer to that question. The last question, very easy, very similar to what I was doing there. It's also in your textbook. A lot of people, I have solved this with the grade 11s in their group. I gave you the notes. You have got the length here. So again, length scale factor is 120 over 80. You see, I always want to work with the improper fraction, the big one on top. So when you play around with this, you're going to get 4 over 3. Okay, because 4 goes there 3 times and 4 goes there 3 over 2. Okay, you can use your calculator, you will see that you get 3 over 2. So that's the length scale factor. So I'm dealing with area. So to find the area scale factor, I am simply going to take this distance and I'm going to square it, squaring it, okay? Because I just want to find the area. But I want to find the area of a bigger one. So when you do this, you're going to get 9 over 4. So in order to find the area of the larger one, I'm going to take my 1/4 that I was given. I'm going to multiply it by the improper fraction. And when you do that, you're going to get 9, because 1 times 9 is 9, over 4 times 4, which is 16. Some of you are giving decimal values, 0. Well, you can also write it down. It's the same thing, 5625. But this is generally the one we're looking for. So both these answers are acceptable. Thank you very much. Now, for those learners who are doing extended and the higher level learners as well, grade 12s, I am going to post an hour from now your test on trigonometry. Now, trigonometry, I'm going to divide it into a few parts. So, trig test 1, Sunday, I want this test by Tuesday. You must send it because I'm going to post the corrections of that test. I'm going to look at bearings, which is the core part. I'm going to look at Pythagoras, the theory of Pythagoras, right? This working with right angle triangles, okay? And I'm going to start off also asking you questions on reverse. There's bearings and there's reverse bearings. Please make sure that you get it. I'm going to give you some word problems that has to deal with this. And I'm going to start also with the sine rule, okay? I'm going to give you a question on the sine rule and also on the cosine rule. So these ones are for non-90 degree triangles. No? The triangles are not really 90 degrees. So other types of triangles where I ask you to calculate the missing side. But I'm just going to ask you very small questions because this will be part of my second test. What I do need to bring in, however, will be your trig ratios. So your trig ratios, which is your sine, cosine, and tangent, all right? Cosine and tangent. So I'll giving you a lot of these, and here I'll just bring in one question just to see if you're on the right path. Actually, there's also one more thing, how to find the area of a non-90 degree triangle, which is a half times AB multiplied by the sine of C, all right? So I'm going to look at this. This is the new concepts that you need to understand. The second test will be more about this. The third test will be a mixture of all of that plus something that has to do with what I'm going to call the cast diagram. Actually, we have it from here. The cast diagram is just something that we use to find where you have an ambiguous case. You'll understand later. So prepare bearings, Pythagoras, your basic ratios, trig ratios, the sine, the cosine, the tangent ratio, and at least a question on of these. It's going to be out of 30 marks. So I'm going to post it. The time now is exactly, what is the time? 4:38 in the afternoon. I'm going to post this question by 6:30. Mr. Meg signing off. Take care. Stay safe. Coronavirus is real. Thank you.